Hello, everyone. My name is Suzette Campos, and my teaching presentation is focused on RT, Hick-Hyman, MT, and Fitts law. RT, also known as reaction time, is the time from the onset of a stimulus to the initiation of a response to the stimulus. Also, reaction time is a measure of how quickly an organism can respond to a particular stimulus. Some factors that affect one's reaction time may be age, gender, physical fitness, fatigue, distraction, alcohol, personality type, and whether the stimulus is auditory or visual. RT is the last dash point for skill-related components of physical fitness. It refers to the speed at which an athlete responds to an external stimulus. The formula is A plus B log 210. On this next slide, I have an example of Hicks' law with the formula 2 reaction time. I also have the simple reaction time and the choice reaction time. The simple reaction time is irrelevant to a signal stimulus and a single possible response. And choice reaction time is several stimulus are given, but only one must be selected for a response. The more choices a person has, the more information needed processing and the longer it takes to process. A slower reaction time is recorded. It also gives a small graph with an example of Hicks' law. Here I went ahead and included a video with a great understanding to Hicks' law, and it's a short abbreviation of what I just explained with great examples that give us a variety of options to look at.
Hey guys, welcome to this Mometrics video on the Hick-Hyman law, more commonly known as Hicks' law. The law is named after the American psychologist Ray Hyman and the British psychologist William Hick. Hick's law states that the time it takes for a person to make a decision increases as the amount of possible choices increase. So essentially, Hick's law illustrates one's ability to make decisions with different amounts of uncertainty. To fully understand this, there are a few terms you need to be familiar with. Reaction time. Reaction time refers to the time between the onset of a stimulus and the start of a response. Movement time. Movement time is the time it takes to complete the onset of a movement. And response time. Response time is the time it takes to process information and then to make a response. Reaction time plus movement time equals response time. Now, there are different types of reaction times. There is the simple reaction, which is relevant to a single stimulus and a single possible response. Then there is a choice reaction time, which means that there are several given stimuli, but only one must be selected for response. And as Hick's law states, the more choices a person has, the slower their reaction time. There are several factors that affect reaction time. Age. Someone's age can play a role into how fast or how slow they react. As a person gets older, their reaction time becomes slower. Gender. On average, males have a faster reaction time than females do. However, reaction time reduces less with age in females than they do with males. Stimulus intensity. Increasing the stimulus intensity will also improve one's reaction time. For example, a loud bang will increase our reaction time more than a quiet bang will. Height. Taller people have slower reaction times because of the greater distance that the information has to travel from the person's brain to their active muscle. Shorter sprinters tend to win shorter races. Level of alertness. Being more alert can improve reaction time. Hick actually came up with an equation to calculate reaction time. Reaction time equals movement time plus processing speed times log base 2n. N is the variable for the number of choices. You can find application for Hick's law wherever you look. Advertising companies use it to determine certain features on their websites. Restaurants use it to determine features on their menus, and it's used to output effective commercials and so on. Hick's law helps companies to gauge average reaction times to certain features of their products. Typically, the quicker one reacts to their product, the better. I hope this video was helpful. See you next time.
Alrighty, moving forward, we have Hick-Hyman. Hick's law was named after British and American psychologist William Edmund Hick and Hick-Hyman. The law describes the time it takes for a person to make a decision when presenting more options. Hick-Hyman's law describes the relationship between the time taken to prepare a movement response alternative in which the participants must respond as fast as possible with a movement. Hick-Hyman law. This law presents a challenge, making it imperative to offer the most useful sets of options to avoid frustrating the user. Hick law also discovered that mathematical relationship between response and reaction time. Hyman was responsible for determining a linear relationship between reaction time and the information transmitted. The formula for RT, again, it's A plus B log2n. MT, also known as movement time, is defined as the time from the initiation of a movement unit until its completion. This formula appears to show a relationship between the speed and accuracy of movement. Fitz found that the movement time in this task could be predicted by the following formula: A plus B log2 2A over W. Fitz performed experiments showing that the time to complete a movement was dependent on two factors: the movement distance and the size or the width of the target. Paul Fitz. Fitz was born in 1912 and died in 1965 due to a heart attack. Paul Fitz was also the first psychologist to develop a model of human movement. Fitz was the first to establish a quantitative relationship between the speed and accuracy of movement. Paul Fitz's law was initially created with main purpose of predicting performance. In this next slide, I have an example of Fitz's law along with the formula for MT. And I included a video that helped me get a better understanding of what Fitz's law was and what his initial purpose was when creating this formula. I hope this gives you guys a greater insight.
Would you believe that one of the most important, fundamental, and common sense laws of design is also one of the most frequently ignored? We can't believe it either. You may or may not have heard of Fitz's law, but if you've designed any interfaces, you've almost certainly used it. A researcher named Paul Fitz created a model that describes how quickly people can select a target. It's important to know this law if you're designing websites, mobile apps, device interfaces, or even physical dashboards. Fitz's law says that the time to acquire a target is a function of the size of the target and the distance to the target. Here's the equation. The important variables are the target and the distance to that target. A target is what the user is trying to interact with. Maybe it's a button to tap or a form field that needs to be clicked into. The distance to the target is how far away that target is from wherever someone starts out. Large targets that are close by have the lowest interaction costs, while small targets that are far away have the highest interaction costs. Here are a few common applications of Fitz's law. Buttons to complete an action should be close beside the active elements. Important actions should be larger so that they're easier to select. With menus, drop-downs, and any type of interactive list, shorter is better. This is a guideline rather than an absolute rule. Sometimes a list has to be long to show all of the options that users need to see. This seems like common sense, but it's one of the most frequently ignored laws of design. Remember that large targets and less time needed to find them keep interaction costs low.
Alrighty, moving on. We have Fitz's law. The law was based on rapid aim movement, which went on to become one of the most highly successful and well-studied mathematical models of human motion. Fitz's law is a predictive model of human movement, primarily used in human-computer interactions and ergonomics. The scientific law predicts that the time required to rapidly move to a target area is a function of the relation between the distance and to the target and the width of the target. Fitz's law gives us a way to compare tasks, limbs, and devices both in manual as well as in computer pointing. This law helps conclude that, that devices with higher pointers of performance would be faster and much better. That is all I have for today. Thank you so much for tuning in.